Select the best reagent or set of reagents for the following transformation. So you want to look closely at the structure of our starting material and at the product to see what has changed in this reaction. So we see our starting material has a ketone, an ester, and an alkene. And if we take a look at the product, our ketone has changed to a secondary alcohol. So we want a reagent that will take a ketone and make a secondary alcohol. And then we see that we still have the ester and we still have the alkene. And these are both functional groups that could also be reduced. Going from a ketone to a secondary alcohol is a reduction. So we want a selective reduction here. And we're calling it selective because we want it to find a reagent that will reduce the ketone, but not react with the ester or the amine, or the, the ester or the alkene. So the reagent that we're looking for that would do that is this option here, B, sodium borohydride. And so this is a mild reducing agent. So sodium borohydride reduces ketones to secondary alcohols, and it will also reduce an aldehyde to a primary alcohol. And if we take a look at some of our other conditions here, hydrogenation with Raney nickel, this is a stronger catalyst. So these conditions here in A, this would reduce that alkene for sure, it's a hydrogenation. So it would take the alkene and give you an alkane. And this is also strongly reducing enough to react with the ketone. So it would reduce the ketone to the secondary alcohol, but it would also have reduced that alkene. So that's why we don't want to select this one. So it would take a ketone to a secondary alcohol. And this would also reduce an aldehyde, same as we had here, an aldehyde to a primary alcohol. Okay, if we look at the option C, this is lithium aluminum hydride. That is the most powerful reducing agent that we've seen. And this reacts with polar pi bonds. So this is not going to react with your alkene, but it would react with the ester and with the ketone. So this would reduce the ester and the ketone. And so this one is interesting. Let's take a look at what this would do. So I'm using my pencil here so I can erase some stuff. Because with the ester, it's actually going to break this group off. So this is what we would do. We would form the secondary alcohol here from that ketone. And when we reduce the ester, we're going to make two different alcohols. So we'll make this alcohol, so we'd end up with a diol, and we'd also have this fragment. So we get two different products out of that because we're breaking the molecule in half. And then the final conditions that we're looking at here, this is just typical hydrogenation conditions. So this would reduce just that alkene. So this would reduce the alkene to the alkane, and it would not react with the ketone or the ester.